Hello, in this session we are going to describe how to name organic compounds. Welcome. In order to effectively name organic compounds, it will be suitable to evaluate primarily the general formula carried by each species in order to get its family before you proceed to representing it in a displayed formula and naming it comprehensively. Let's take a look at the first example in which we have C6H12. And I would want maybe just to say that the core families or homologous series include CnH2n plus 2, which represents alkanes. Then we have CnH2n, which represents alkenes. Then we have CnH2n minus 2, which represents alkynes. Now, alkenes are single bonds, alkenes are double bond hydrocarbons, and alkynes are triple bond. Therefore, whenever you see an organic molecule with a formula which corresponds to any one of these, you can identify directly by saying an alkane, the number of hydrogens is twice the number of carbons with an excess of 2. For an alkene, the number of hydrogens is twice the number of carbons exclusively. For alkynes, the number of hydrogen is twice the number of carbons with a deficiency of 2. Beyond this, there are two other families which can lead us in the sense that when you have an organic compound of the formula CnH2n plus 1 joined to OH, it represents an alkanol. Therefore, the identity of alkanols is just an OH carried by an alkyl species. And beyond this, we have the CnH2n plus 1 joined to COOH. In this case, we have the carboxylic acids or the alkanoic acid, and we proceed and say that whenever you see that an organic compound has a carboxylic group, then primarily is an organic acid or a carboxylic acid. Therefore, how do we name the first species? Looking at the first species, I can clearly see that the number of hydrogens is relatively twice the number of carbons exclusively. That means it's a species in the family of alkenes. And being an alkene, it follows then that it carries a double bond at least between two successive carbons. To represent it, therefore, we are going to represent all the carbons in a row, 1, 2, 3, 4, 5, 6, and then proceed to attach at least a double bond after the first carbon. Remember, the first carbon will be attached either on the right-hand side or on the left-hand side, regardless of how the molecule has been represented. Then we proceed to represent the number of hydrogens, in this case, following the carbon rule, which says each carbon carries at most 4 bonds on it with no exceptions. Therefore, we will say that the primary carbon, which has 2 or a double bond, will carry only 2 hydrogen atoms. The secondary carbon to the primary will carry only 1 hydrogen because it already has 3 bonds. And the subsidiaries will carry 2, 2. Again, exclusive of the outermost or polar molecule, which will carry 3. Now, to confirm this, we need to count the number of hydrogens in respect to the number of carbons. First, there are 1, 2, 3, 4, 5, 6 carbons. Secondly, the hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means we have represented the molecule effectively. How do we name it then? We name it from the side closest to the functional group, which is a double bond. We begin by counting the number of hydrogens, which are 6, and the prefix for 6 is hex. The position of the family is the first carbon, so hex 1. The family is alkene, so in. And then we find that the name is hex 1 in. Number 2, I can see that we have a formula C6H10. When I multiply 6 by 2, I get 12. I subtract 2, I get 10. It means that formula corresponds to the general formula of alkynes. Therefore, as I represent it, I will represent a chain of the 6 carbons in a row. But since the formula is of alkyne, I remember alkynes have a triple bond, so I place a triple bond after the polar carbon and attach single bonds on the rest. Then, following the carbon rule, I affix hydrogens in their respective positions, and as I do so, I take a keen view into the number of bonds around each carbon, and this leads me to that structure. Now, when you look at that structure, counting the number of carbons is 1, 2, 3, 4, 5, 6. Hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have satisfied the representation of the displayed formula for the molecule given. What name does it carry? We've said that it is an alkyne with 6 carbons, and therefore we call it hex 1 ine, where 1 represents the position of the functional group which is after the first carbon. Next, we have C6H14. How do we represent C6H14? C6H14, I can see clearly the number of hydrogens is twice the number of carbons with an excess of 2. That formula corresponds to that of alkanes. Therefore, to represent it, I will represent it exclusively with single bonds, with a chain of 6 carbons in a row, single bonds within them, and following the carbon rule, I affix hydrogens respectively, ensuring that there is no surplus, no deficient attachment to each carbon. And as I do so, I should satisfy the molecular formula of 6 carbons alongside 14 hydrogens. Counting is 1, 2, 3, 4, 5, 6. Hydrogens is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. I've satisfied that requirement, and since there are 6 carbons, I will give it a name of an alkane with 6, which is hex N. So this is an hexane molecule. And next to that, we have a molecule with an outstretched molecular formula. In this present case, I only need to take a keen view as to how many carbons are present. And then I will attempt to articulate based on the foreign species they are on and following alphabetical listing. So in my counting, I can see that I have 1, 2, 3, 4 carbons. That indicates to me that this is a butane molecule. Now, it may not be N, it could be in or ine, so it's a but molecule. Next to that, I have some foreign species. You can see there is a bromine and there is a chloride. Now, the position of Br and Cl will be labeled in respect to the alphabetical listing. In this case, bromine starts with B, so B comes before C, which is chlorine. That indicates to me that for me to name this species, I'll name it from the side closest to the alphabetical listing. In this case, B is on the right-hand side, so I'll name it from the right-hand side, looking at the number of carbons, which is 1, 2, 3, 4. So it's a butane, but this butane or but molecule carries bromine in position 2, which is the second carbon, and it carries chlorine in position 3. So I could name it as but, as a butane or butane, but then I will begin by the foreign molecules. In this case, the first foreign molecule is bromine, so in position 2, so I'll say 2 bromo. The second one is chlorine in position C, so it's 3 chloro. And the family is but. Now, I don't know whether it is N, in, or ine. So what I do, I draw the displayed structure, which is 1, 2, 3, 4 carbons in a row. I assume primarily there are single bonds. I affix the foreign molecules, bromine and chlorine. Then I proceed to affix the hydrogen molecules to satisfy the molecular formula as provided. Now, once I satisfy that requirement, I confirm it. How many hydrogens are there? 3 plus 1, 4 plus 1 is 5 plus 2 is 7. 2 plus 1 is 3 plus 1 is 4 plus 3 is 7. So if I have more than 7, then it means not correct. If there are 7, it's correct. Now I have 1, 2, 3, 4, 5, 6, 7, and I can see I have an 8 there. That means it's not correct. So there has to be a double bond. So now you see, now I have changed from what was butane to butene. Confirming, now I have 1, 2, 3, 4, 5, 6, 7. So that is a what? A butene. Now, the double bond has been represented on the side closer to bromine. So that is a clear indication that I'm still going to name it from the side close to bromine. In this case, I have 2 bromo, 3 chloro, but, 1 in. What will be the case in the event that the bromine was on the left-hand side? It will still mean that if as supposedly that we had 1, 2, 3, 4, and the double bond happened to be on the left-hand side, which is not the case because we have a CH3. So I'll just leave that and let us do the next one. We will still name it from the side closer to the functional group because the functional group takes precedence over the alphabetical listing of foreign molecules in a hydrocarbon or organic compound. So that is 2 bromo, 3 chloro, but 1 in. Next, we have a structure here following the same sequence. If you allow me to use a different color, the carbons are 1, 2, 3, and 4. That's also a but molecule. The foreign molecules are bromine and hydroxyl. Their respective position following alphabetic order is Br, B, and OH hydroxyl H. So B will come before H. However, in keenly looking at it, I can see that both the first and the second have to be drawn. So we need to draw the structure to verify. So drawing the structure, we'll have to draw for 1, 2, 3, 4. Then looking at each respective molecule in the structure, we proceed to attach the foreign species. The first one has 2 hydrogens and a bromine, or a bromide. Yeah, 2 hydrogens and a bromide. The second one has a hydrogen and a hydroxyl. The third one has 2 hydrogens. And the fourth one also has 2 hydrogens. Now, following the carbon rule, it means there's a double bond. And that is a complete structure. Now, analyzing this again, I can see clearly that there is an OH and there is a bromine. However, even though bromine is on the left-hand side, I will not name it from the left-hand side, but from the right-hand side, since there is a functional group on the right-hand side, which is a double bond. Now, giving the respective positions of carbon, we have 1, 2, 3, and 4. The procedure for naming says begin with the foreign molecules and their respective position following the alphabetical listing. In this case, we have bromine and hydroxyl. B comes before H, so we will say 1 bromo, 2 hydroxyl. Is it 2? This is not 1 even, it is 4 because it is named from the right hand side. So it is 4 bromo, 3 hydroxyl, then it's a but1-ene. But1-ene. So we can comprehensively say that this molecule is 4-bromo-3-hydroxy but1-ene. However, we could also be allowed to take hydroxyl as the primary organic family, depending on its derivative point. In this case, we will say it is a butanol, and this butanol is in position 3. So in that case, we will say it is 4-bromo-butanol. 4-bromo-butanol. Good. Now, 4-bromo-butanol, and the position of the ol is 3. But3-ol. Yeah. 4-bromo-butan3-ol. Next, we have a molecule which has a varied range of carbons. There is 16 plus 1, which makes 17, so that is 17 alkyls with the carboxylic group. Now, in this present case, the carboxylic group takes precedence, which means this is an organic acid. And the number of carbons in this organic acid are 18. And therefore, to name the first 10 is a dec. At the end subsidiary after the 10th, we affix new prefixes like uni for 1, di for 2, tri for 3, tetra for 4, and then penta for 5, hexa for 6, hepta for 7, and octa for 9. So we will say this is an octadecanoic acid. Octadecanoic acid. Now, the position of the carboxylic group will also modify the name because it's on the outermost carbon, so we can say it is also octadecanoic acid. So either octadecanoic acid or octadecanoic acid. Octadecanoic acid or octadecanoic acid is the name of that molecule. In summary, therefore, in order to name organic compounds, we must primarily look at the number of carbons present, which gives us the prefix. Number 2, we look at the functional group, which is determined by the general formula. Number 3, we look at the foreign molecules and begin naming it from the position of the foreign molecules and with greater preference to the side in which the functional group is found. And then you proceed to name it following the carbon rule and maintaining the nomenclature sequence. Thank you.